Back geometry students, this is Mrs. Thompson. We're getting ready to jump into section 5.7, example 4, and these are the two theorems that we're going to cover in this particular example. These need to go into your electronic notebook, but I did want to go over them. The converse of the Pythagorean theorem is basically, this is what it says: if the sum of the squares of the lengths of two sides of a triangle, if they're equal, if that sum is equal to the square of the length of the third side, then the triangle is a right triangle. So if you're not, basically what it's saying is if you're not sure it's a right triangle, all you have to do is plug each of those sides, your longest side in for the hypotenuse and the shorter sides in for the legs, A and B. If it works out in Pythagorean theorem in that equation, then it's a right triangle. So when you were working with the Pythagorean theorem, we were working from the premise that it was already a right triangle, and we were using that premise to find missing angles. Because we already knew that there's a relationship that existed there, that if we added the square of the two legs, it should equal the square of the hypotenuse. We already knew that that relationship existed. And so because it was a right triangle, now we're proving it's a right triangle. And we do that by finding the three side lengths. We don't know any angle measures. We find the three side lengths, plug them into the Pythagorean theorem, and if it works out, then we know, oh, if it works in the Pythagorean theorem, then it must be a right triangle. Okay, so that's the converse of the Pythagorean theorem. Now, down here, we've got the Pythagorean Inequalities theorem. And this is really cool because you can, if the Pythagorean theorem works out to be c squared exactly equals a squared plus b squared, then we know that that's a right triangle. If it equals, that's the kicker right there. If it equals, the square of the hypotenuse equals the square of each of the legs added together, okay, then here's where we can kick it up a notch. We can actually determine if we're dealing with an obtuse triangle or an acute triangle using the Pythagorean theorem, the inequalities theorem. And so here's the first one. If c squared ends up being bigger than a squared plus b squared, then you have an obtuse triangle. Isn't that cool? That's way, way cool. So you can actually use the Pythagorean theorem, compare the square of the hypotenuse to the sum of the squares of your legs, and you'll be able to figure out what kind of triangle you're working with. So if they equal each other, it's a right triangle. If the square of the hypotenuse is bigger, then it's obtuse. If the square of the hypotenuse is smaller, then it's an acute triangle. Isn't that neat how you can tell using one formula? You can tell all this. All right, flip the page and let's classify triangles. Tell if the measures can be the side lengths of a triangle. Got to do that first. Got to see if we even have a triangle first. And then if so, then we're going to classify it as acute, obtuse, or right. Sounds great. Let me show you how to do the first one. And then I'll do the first two, and then you guys will do the check it out for extra credit. So we'll leave this one down here, 1 point for each of these, extra credit for the check it out. Okay, so step 1, determine if the measures form a triangle. If you recall, this is the Triangle Inequalities theorem out of section 5.5, and basically just to kind of remind you what this says, if two sides should be greater than the third side. It doesn't matter which two sides, and you want to test all of the pairings there. So for example, at 8 plus 11 should be bigger than 13, and it is. 19 is bigger than 13. 11 and 13 should be bigger than 8, okay? And it is, because 24 is bigger than 8. And then 8 and 13 should be bigger than 11, and it is, because that's 21. Okay, so what that, as you may recall from 5.5, what that tells us is, hey, we got a triangle. We know for a fact this is a triangle because it passed the Triangle Inequalities theorem, okay? Now we get to classify it. We're going to use the Pythagorean theorem to kind of help us along the way. So 8's our smallest side. We're going to call that A. Our middle side length is 11. We'll call that B. Our longest one is always going to be put in the hypotenuse position. So the way you plug this in, you're going to do 13 squared. I'm not going to put a symbol here. In fact, I'll just put a box so we can compare the sides. And then 8 squared plus 11 squared. Okay, so we know 13 squared is 169. 8 squared is 64. 11 squared is 121. And so we need to figure out what 121 and 64 equal. And I've got 185. So the symbol, they're clearly not equal. So this is not a right triangle. 169 is smaller than 185. So when the square of your hypotenuse is smaller than the sum of the squares of your legs, then what you have is an acute triangle. And so that's the way we can classify it. Like, hey, the triangle is acute. We got it. Okay? That's what they're after. So first determine that it's a triangle to begin with. Are the sides long enough to even make a triangle? And then as soon as you determine that it's a triangle, then you can go into it and go, okay, now we can put it into the Pythagorean theorem and decide if it's right, obtuse, or acute. Okay? So let's look at B. So step 1, determine if the measures form a triangle. All right, so let's start with these two. 5.8 plus 9.3. Those two together should be bigger than that third side. Okay? So 5.8 and 9.3, that looks like 15.1. Uh-oh. That's not bigger than 15.6. So this is not even a triangle. So I can't classify it. It's not even a triangle because it didn't even pass the Triangle Inequality theorem. And that may happen. So I wanted to show you one where it did work out. It was a triangle. You ended up having to classify it. In letter B, it just didn't pass the first test. It's not even a triangle. Doesn't form a triangle. Okay, so I'm going to leave these 3 for you. Go, go, go. Those are for you. Test out, make sure, do Triangle Inequality theorem and then Pythagorean and see what you find out. Okay, bring your questions to class if you have any.